Hi everyone, in this video I'm going to go through how to use the tracker software to analyze the videos for the conservation and momentum lab that we're doing today. This will be review because this is the same software that we used in the 1D kinematics lab back at the beginning of the course. So if you could please go to my links on D2L and download the tracker software. It's free for everyone, so hopefully we can all try this. And then once you have that, open Tracker and then go to my Dropbox link and download the momentum videos. So we have two different videos here. One is of elastic collision and one is an inelastic collision. So I'm just going to show you the elastic collision first. So I'll just open that and play it. This is the air track in the lab, so friction is reduced. Of course, it's not zero, so we know there's no perfect elastic collisions on the macroscopic scale, but this can be a good approximation. So the carts collide. All right, now I'm just dragging the video over into Tracker to open that. I had to record my voice over this, so I'll try to my best to keep up with all the cues. Okay, so now we need, in order to analyze, let's make an XY axis in our video. So you can line that up with the bottom of the track and then adjust the angle. I thought about 0.3 degrees worked best. And then we need a calibration stick to set a scale for the video. So go New Calibration Stick and then shift click on either side of those bars of the air track. You can line that up parallel with the track. And that's 30 centimeters. So I'm going to click that, backspace, and put 0.3 meters. All right, so I'm going to drag this over because if you notice, the video didn't start until almost halfway through. What we want to do is create a position versus time graph for each cart before and after the collision, and then we can use the slope to find the velocity. Okay, so go to Track, New, Point, Mass, and now shift click on a part of the cart that you can easily be consistent with. So I use that black corner at the end. There's a little mark on the bottom of the cart, but it's kind of hard to see in this video. So the carts were given a push, and since it's roughly frictionless and horizontal, they move at roughly a constant speed. You can see as we go, you can be more careful with this than I was, I'm going a bit quick, that we're getting a straight line almost for our position versus time graph. So it is roughly a constant speed there. And you can just continue with this until just before the carts collide. So shift click every time, and my video isn't on play, it's still stopped. So, all right, now right click on the graph and go to Analyze, and then Analyze again and pick Curve Fits. Now it will be on the line. If it's not, select Line, and that's the value that you need, actually just the A, because we only want the velocity from the position versus time graph, which is the slope. So you can record that in your data table. Now we'll repeat. We want to track mass 2 as it approaches before the collision. So just getting it right to the point where it's about to start, and then track new point mass again. And then, all right, so let's do shift click again on mass 2, mass B, and this will be glider B, VXI. So shift click, all the way up until it just before it collides with mass A. And again, we can see our position versus time graph forming here. You can zoom in if you really want to be precise about this. So what we want to be able to do is to check if the total initial kinetic energy equals the total final kinetic energy. If they're equal, that's an elastic collision. And we want to check that momentum is conserved in the collision. This is why we need all the velocities. So again, right click on the graph, go to Analyze, and then it's on mass B. You can click Analyze again, Curve Fits, and then take value A, which is the slope. So we'll take value A. Notice it is giving us the opposite sign to mass A, which it makes sense because they're moving in opposite directions, and we do need the signs for momentum, so don't forget the signs on your velocities. Okay, so I'm just showing you can keep going if you want. You could also delete the other point masses or even start again and just track the two velocities after the collision in the same way. All right, so I'm just erasing that. I tried a new tab and the memory ran out on Tracker, so you'll probably just have to close and open a new video and then pick Inelastic. So in this one, this perfectly inelastic collision, the two masses will stick together on the air track after the collision. So they're released, they collide, and they stick together. There's some magnets in there. Okay, and so now we can just drag this video. I'll close it and then drag it to open it in Tracker. All right, just waiting for it to load here. And then essentially we'll repeat the analysis again. So what I want to do is now find the velocities of glider A and glider B before the collision, and then the total velocity of the combined mass after the collision. All right, so just showing you again, set the axes here and putting an angle of 0.3. You can try a new angle if you don't think that matches up perfectly. It's a bit of a guess here. Calibration stick, shift click where you want to set that calibration stick. And just adjust that a little bit, and it's 0.3 meters. Okay, so before I do track, I'll just get the video a bit closer since there's some wait time here at the beginning. It's too slow, so I'm going to drag it along. Okay, and now we're ready to go. So track, new, point mass. This time I'm going to start with the mass that's on the left. It really doesn't matter. And then shift click as you go so you can see the corner marker better in this video. Shift click, and I won't do it all, but you'll get the velocity here, and then you can repeat for the other mass before the collision. So since this is a perfectly inelastic collision, we would expect momentum to be conserved. I mean, there are some external forces, so not even that would be perfect. But then elastic, and it would not be elastic because the masses stick together. So we know kinetic energy is definitely should not be conserved in this collision. All right, right click, analyze, and then we're going to hit analyze again if it's not there. Looks like this one is, curve fits, and then it will give you the value there. And you need A, the value of the slope, which is the velocity. And again, it should have the right sign. Okay, so just showing you after they collide that you can choose any point again on that combined mass as long as you're consistent about where you're clicking to track the data. So shift click again anywhere on that mass. You can add a new point mass the same way every time, new point mass. And then this one's quite slow actually, and then it will add the position versus time graph on the right. Okay, so when you have all of those velocities, then you can just answer the questions on the worksheet, and that's all that's due this time, just the worksheet. So you can fill that in, show your work, and then comment on how the results compared.